everybody, Carl Larson here with a really practical tutorial for you today. In this lesson, I'll be showing you how to build an expression-based vehicle rig that automatically calculates the rotation of its wheels based on the overall movement of the vehicle chassis. And this is important because at one time or another, if you stick around motion graphics long enough, I guarantee you'll have to animate something with a wheel in it at least once in your career. And the more comfortable you can get with expressions, the better of an animator you'll become. So whether it's a car, wheelbarrow, set of gears, or a tractor, all of these principles will apply. And when the situation arises, you'll be ready to impress the socks off of your clients and have a much easier time making revisions to your projects. So let me show you the inefficient but quick way this is typically approached and why using expressions is a better option. First, we'll import our file. Choose Composition Cropped Layers to be sure that our wheels rotate around the center of the wheel, and click OK. Double-clicking on the composition, we'll change the background color to something lighter so you can see what's going on here, and change composition settings to make this a standard size. And we just animate this real quick. So the first thing we do is select the front and rear layers, parent them to the body, grab the body, start it in one corner, press P on the keyboard, set a keyframe, go a couple seconds down the timeline, and move it over. Now, naturally, there's no movement going on with the wheels here, so we need to also set some keyframes for the rotation of the wheels. We'll grab both layers, press R on the keyboard to reveal the rotation property, move back to the beginning of the timeline, set a keyframe, and jump to the next keyframe, and then just choose an arbitrary value. This is the problem. You basically have to guess, so we'll just crank it up here and take a look at that. Okay, so that's way too much. And just to further complicate things, we have different sized wheels. If we get one of them right, the other is still going to be wrong. Now, admittedly, if you played with this long enough, you can get it pretty close if you just are going to have your vehicle go across the screen and stop. But what if you have to race the vehicle in, ease it to a stop, have it back up a few feet, and then drive out on the other side of the frame? Getting that right might take forever, and making revisions on that would be even worse. So what's the solution? We need to establish a relationship between the rotation of the wheels and the movement of the vehicle using expressions. Then it will be a piece of cake no matter how you want to move the vehicle. And better yet, you won't be a grumpy animator when the client asks you to make revisions on the timing of the animation. I mean, hey, nobody likes a grumpy animator. So let's do a quick review of the math that we'll need to use in our expression, and then get to the coding. The circumference of a circle is pi d, where d is the width of your circle, and pi is roughly 3.14. So in our case, the rear wheel of the tractor is 210 pixels wide, resulting in a circumference of 660 pixels. This means that for every 660 pixels the tractor moves, we want the rear wheel to rotate 1 revolution. But we need to write our expression in terms of pixels and degrees, so 1 revolution equals 360 degrees, and we want this to happen over a distance of 660 pixels. As a result, the tire will rotate 0.55 degrees per pixel of movement. Therefore, our final equation will be rotation equals 360 degrees divided by the circumference of the layer multiplied by the pixels traveled on the x-axis. Great! Now that we understand the theory, let's translate that into something After Effects understands. So option clicking on the rotation property of the rear wheel, let's start by defining a few of our variables and then combine them into our final equation. So d equals width, semicolon. You can find this in the expression flyout under Layer General, Width, if you don't want to type it, math.py semicolon. You can find this in the expression flyout under JavaScript math, pi. Now we'll multiply our variables together to define our circumference of our layer. Circ equals d times pi. Be sure to add a semicolon after each variable is defined. I always used to have problems with my expressions until I learned that little bit of syntax. Next, we'll define a variable for the rotation of the wheel. Rotation, ROT, equals 360 divided by circumference, semicolon. This gives us the value for how much the wheel should rotate based on the number of pixels that we move the tractor. Finally, we'll define a variable for the movement of the tractor along the x-axis. So we'll call this movex. So movex equals, then pick whip to the x value of the position property on the body layer, and let go, semicolon. Now we'll define our final equation using the variables that we've created. Rotation times movex. Press enter on the keyboard. Press the tilde key to reveal our composition again, and let's do a little keyframing here on the body layer just to see how we do. So at the beginning, we'll set a keyframe, go back out to 4 seconds, scrub along, and looks like our wheel is working perfectly. Now let's copy and paste the expression onto the front wheel and take a look. Option click on the rotation for the front layer and paste it in. Now the rear wheel and the front wheel rotate at varying speeds, but correctly based on the expression that we've provided. Very nice. But what if we need to rescale our layer to set things up? Let's give it a shot. Pressing S. We'll scale the main body down and see what happens. Our wheels are still rotating at the same speed that they did at 100%. Well, what's going on? It turns out we don't have anything in our expression to relate the scale of the object to its rotation. So we need to define a new variable and update the final equation. Not that big of a deal. So back in the expression, let's define another variable. Scalar equals, and pick whip to the x or y value of the body layer. These should always be the same, so it really doesn't matter which one you choose. Just don't pick whip the scale value itself. If you do, the expression will be attempting to calculate for an array, both the x and y values, and it won't work. Next, take this value and divide it by 100. This will give us a scale factor we can use in our final equation. When the scale equals 100, we'll be dividing our final result by a factor of 1 and have no change in the scale. When the scale is 50, the final result will get divided by 0.5, which will make the wheels rotate twice as fast, which is exactly what we need. So now it's time to update our main equation. Instead of it reading rotation times move x, let's add one more factor to this and go divided by scalar. So rotation times move x divided by scalar. We'll copy the code out of here, paste it on both wheels, and it looks like it's working perfectly. Let's scale the layers back up. So at 69%, everything still works great. 85% still works. 100%, and it still works. Now we can make the tractor zoom into the frame, back up, creep forward, pop the brakes a few times, and exit our frame, all with a few keyframes on our body, instead of trying to animate separate properties on separate layers, all by guessing. And now that you know how to set up your vehicle rig using expressions, I hope you wouldn't choose to do it any other way. So until next time, I'm Carl Larson for CreativeCow.net.